Alright, in this video, we are going to look at, that is limits of functions. Limits limit of functions. Now we are done with looking at limit of sequence functions. And now we are coming to the limit of functions. So the first one is limit of function, let's say part 1, and this is limit of functions part 2. Alright, so in general, we are going to geometrically present the idea of whatever that we are going to do, and that is from the diagram. We have the function f of x. Now, it's always a function in terms of what? X. Don't forget that our previous examples and our previous studies, that one, it was sequence, so it was involving with what? A variable x. But this one is going to be involved with it's going to be a function which is in terms of x. Very good. So that is what we are presenting here to you. Alright. So now you can see that as x approaches A, the function f of x gets increasing. As x approaches the A, the function of x continues to what? Increase. Now, in analysis, we need to prove this. By giving an equivalent statement. Everything that we do in as far as this course is concerned, we need to prove it. And we can prove this by issuing an equivalent statement. Now, when you take a limit, when we say that as x approaches A, the function f of x gets increasing. Now, it means that when you take the limit of the function as x approaches A, you are going to get a value, and that value is f. Alright? It's going to be bounded to a certain value, and that value is f. When L belongs to all right numbers, that means that the L keeps on increasing. So at this level, the L is that. Very good. Alright. So we issue the equivalent statement here. Then we say that if given any positive epsilon, that is, this is called epsilon. Alright. If given any positive epsilon, that is epsilon being greater than 0, that means that epsilon is positive. So if given any positive epsilon, there exists. What this means that it is called there exists delta. This sign is called delta. Alright. There exists delta, which is in terms of epsilon being greater than 0, such that the absolute of x minus A should be greater than 0 and should be less than delta. Very good. Alright. Don't also forget that the absolute here means that the x, what is the variable of the function, should be negated. Should not be negated. Very good. And also the A here can represent any value. Alright. It can be 1, it can be 2, it can be 3, but it cannot be 0. It can be 0. Alright. But it will depend on the person. If it can be 0, it will depend on the person. So without wasting much time, we will solve our first example. But please take note of these things. Anytime you are given a question to prove, you need to state the condition. You need to state the theory. The theory says that you start from here. If given any positive epsilon, there exists delta in terms of epsilon greater than 0, or there exists delta in terms of epsilon positive, such that then that is equal to that. So when a person is given to you, you will first write it in this form. Please watch. You start with this. You first start with this. The question will be a function of f of x, which is equal to L. The L can be any number. For instance, 2x plus 1 is equal to 2. That, so you are going to prove. So you'll be giving that in the limit. When you are solving the first question, you get to know it. Alright. So this will represent the f of x, then this will represent the what? The L. Then you do the substitution. So you replace the f of x to where the f of x is. Then you manipulate it with your algebra in order for you to get something like x minus a certain value. And when that is achieved, that means that you have arrived at your final answer. Let's see how that is going to be with our first example. Prove that so you start with the theory. If given any positive epsilon, there is delta in terms of epsilon greater than 0, such that very good. So for me, I'll skip that part, but for you, you have to bring it. Prove that alright. 3x, the limit as s approaches 1. The limit as s approaches 1. 3x minus 1 is equal to 2. Okay. Yes. I'm sure by now you are saying, oh, but it's true. It's true because when you are taking the limit as s approaches 1 of this function, you just replace the s by 1, so you get 3 minus 1, which is 2. It's true, but here we want you to prove it. Alright? We want you to prove it. So you have to state the theory. If given any positive epsilon, there is delta in terms of epsilon greater than 0, such that, don't forget, it says that 0 less than x minus a is going to be less than delta. Alright. Now, what determines this a is where the limit is approaching. Don't forget that. Always don't forget that. So here, the a here is the 1. Alright. So we try to achieve this. That is what we want to achieve. That is what we want to achieve. I want to take my time to explain this deeply to you. That is what we want to achieve. So we start. We start with f of x minus L. Alright. That's what we are going to start with. We are saying that, yeah. So that is f of x minus L less than epsilon. So from the question we have here right now, the limit as s approaches 1, 3x minus 1 is equal to 2. This that we have here, we are going to rewrite it in this form. F of x minus L less than epsilon. Now, we know that the f of x here is 3x minus 1. The L here is representing 2 less than epsilon. So with your algebra, this will be 3x minus 1 minus 2 less than epsilon. And this is going to give you 3x minus 3 less than epsilon. So don't forget that what do we want to achieve? What do we want to achieve? Alright. So what we want to achieve is that we get x minus the value that the limit is approaching, which is 1. Alright? Very good. So that we can choose, oh sorry, here is supposed to be delta. So in that place supposed to be delta. Very good. This is supposed to be delta epsilon. Then this is supposed to be delta. Alright, so that is that. So yeah, to be able to get 1 here, we have to factor 3 out. And we get x minus 1 less than delta. So we can bring 3 out. Then x minus 1 less than delta. So when you get to this part, alright, when you get to this part, you know what you do to this side, you do the same thing for what? This side. So when you factor out this 3, don't forget that there is a condition, and that condition is that here should be less than. Okay, so yeah, so what will come out here should affect this side. Alright, so here we are going to get x minus 1 less than 3 delta. Then we choose. So here we are going to choose. We choose. How do we choose? We choose so that we choose delta so that it can come and cancel the 3 there to be left with epsilon. So here we choose epsilon over 3. Hope you can see that. So that when you multiply this by the 3 will go and it will be left with what? Epsilon. For us to be able to achieve what we have here. Alright? Very good. So here x minus 1 less than 3 times this cancel this, then we get x minus 1 to be less than epsilon. So we have been able to achieve what we have here. We achieve what we have here. And since we have that to be achieved, then we can say that the limit as s, the limit of the function 3x minus 1 as s approaches 1 is equal to 2. Very good, very good. So that is what we are going to get for that. Don't be confused when you get to this side. When you factor out the 3, alright, what we do is that let this 3 go and affect this so that we can have this to stand alone. So that we can have only this to stand alone. Alright. Now, Or you can also do it this way in case that letting this train to affect this is what is confusing you. No problem. The idea is that you want to get this, that is all. So somebody can choose to do it this way. Divide both sides by 3. So here we get delta over 3. But when you choose delta, you have to make sure that the delta you are bringing will come and cancel this 3. So here, you are not going to choose epsilon over delta, but rather choose but rather choose 3 epsilon. Rather choose delta to become 3 epsilon. So that when you do the substitution here, 3 epsilon over 3, this will go, then we get this less than epsilon. That one is acceptable. And I hope you are not confused about it. Whether you go by this way or the other way, it's still the same thing. Alright. Looking at the second question, here we have to prove that the limit of the function x over 2x plus 1 as x approaches negative 1 is equal to 1. Now clearly, you can see that when we put x to be equal to negative 1 into the function, we get negative 1 over 2 negative 1 plus 1. And this will give us negative 1 over negative 2 plus 1. So you get negative 1 over negative 1, which is 1. It is true, but we don't want you to show it algebraically like this. We want you to go with the idea of analysis to prove it. So to prove that this is equal to this, then we have to issue an equivalent statement to say that if given any positive epsilon, then exist delta instead of epsilon greater than 0, such that this, then that value. So here you can even choose to write it like this. And always you have to start by stating the theory. If not, you are going to get it wrong. You can state it. You know that the f of x is x over 2x plus 1 minus. So this is the f of x minus the L, which is 1. Very good. So that is that. It's an average sign. Right. Very good. Then you start solution. So you start by quoting this to achieve this. But don't forget, what's supposed to be here? Negative 1. The A is negative 1. So you are supposed to get x plus 1. Always don't forget that. So x over 2x plus 1 minus 1 less than delta. Then we achieve the same denominator. So to achieve the same denominator here, we get less than delta. Alright, so the negative has made the inside. I hope you can see what we are getting right now. Very good. So, having this, then it's going to be beautiful. Always don't forget where we are getting to. In any proof, you have to know where you are starting and or your starting point, or your initial point and your terminal point. Alright, so this is our starting and this is where we want to achieve. And the A here is -1. So here is supposed to be x plus 1. So let's see if we can get that. So with this, the numerator, we can factorize negative. So when you factor out the negative, don't forget that this is an absolute sign. So it will undo the negative. So no more bringing absolute again. But you can choose to bring it, but it won't affect anything. Alright. So now, what we exactly have here is that we have 1/2s plus 1. Then s plus 1 delta, less than delta. Very good. Now you see, you're able to achieve this to be less than delta, alright, don't worry. So now we are done with this part, but how can we get this? How can we get to the epsilon? That is when, here is when we have to choose the epsilon so that we can get epsilon here. So we choose delta, so we choose delta. And the idea of choosing the delta is that we have to make sure that when we choose the delta, or before we choose the delta, let's do something. As we established in the first example, that you can come and divide the delta here by 2s plus 1. It won't affect anything. To you, it's algebraically wrong without us. But as far as analysis is concerned, it's never algebraically wrong. Alright? It's never algebraically wrong. So you can choose to do that, or you want to go by algebra, multiply both sides by 2s plus 1. So you get s plus 1 less than 2s plus 1 delta. This that we have here, even if it's 1/2s plus 1 times delta, it doesn't cost, it doesn't matter. Alright, very good. So here we choose delta to be equal to, we are going to choose delta so that it can cancel out something to be left with what? Epsilon. Now, let me help you with this. If your problem is on choosing the delta, here you can say that epsilon is equal to 2s plus 1 over times delta. Now, when you make delta the subject, what will you get? You're going to get epsilon over 2s plus 1. Epsilon over 2s plus 1. So when you replace that delta, what is epsilon over 2s plus 1? It's going to cancel out this. Alright, I hope you can see what I mean. So you choose delta to be epsilon over 2s plus 1. So if your problem is on the choosing, you can equate whatever you have here after the less than by epsilon so that you make delta the subject. Times delta, and delta is, so this cancel this. Alright, and we are going to be left with s plus 1 less than epsilon, less than epsilon. Beautiful. And now that we have been able to achieve this, that means that. So what this means is that the statement that the limit as n approach negative one of this function is equal to 1 is true. Is true. Is true. Very good. Thank you for your understanding. If you don't understand anything, you can play back the video again. I'll be back with our third example. Alright, so let's look at our third example. In fact, this is going to be marvelous. This is going to be marvelous. Alright. It's the next question coming from limit of functions under introductory analysis. Alright. So here we have to prove that the limit as x approaches a of this function is equal to 3a squared. And it's true. If we replace a by x, we are going to get this. But we have to prove it by our idea in analysis. We have to prove by analysis that what we are saying is true. So we start with by issuing your equivalent statement. If given any positive epsilon, there exists delta in terms of epsilon greater than 0 such that then hope you can see that. Very good. It's less than it's less than delta. It's less than delta. So where do we start? We start from here to achieve this. Very good. So we have don't forget that the limit is approaching a, so here should go to be f minus a, exactly as what we have there. Alright, so we have to go for the simplified form of x to the power 3 minus a to the power 3. Alright, because if you get a simplified form of this, then we can simplify whatever we have inside here. So how do we go for the simplified form of this? No problem. This is supposed to be algebra, right? And that is going by a long division. Now this is going to be the dividend, which is x minus a to the power 3. So with this, you go for a factor that when you substitute here, you are going to get 0. That means that it's a factor of this. You can see that when we put x to be equal to a, we are going to get 0. Because we will get a raised to power 3 minus a raised to power 3, which is equal to 3. So that means that s is equal to a is a factor. Then we write this as s minus a. So s minus a is a factor of this function. So s minus a. Then we go by the idea of what? Long division. So for that one, I leave it to you for you to do it. Your remainder is going to be 0, 0. Now, in case you be confused, the numbers that doesn't appear, you can represent that by 0. For instance, you don't have coefficient of s squared. You can break plus 0s squared plus 0s, then minus a raised to power 3. You can do it that way. And your remainder is going to be 0, 0. I don't want to go by that algebraic process for you. You should be able to do it on your own. So that. And the quotient, that is what I'm interested here right now. That is going to be s squared plus as plus a squared. Very good. So that's going to be your quotient and your remainder is 0. So this is telling you that when you multiply s minus a, which is the first factor, by the quotient, which is the second factor, you are going to get the dividend. which is x equal 3 minus 8 equal 3. Very good. So instead of writing this, we are going to replace it by this. Hope I can clean it now. So that x equal 3 minus 8 equal 3 is equal to alright, so with this, then this can cancel this, so that it will be like with this and this. Very good. So now here, we are going to get x squared plus ax. Now a minus 3a, here is squared. Alright, so here we get minus 2a squared. Very good. So that is what we are going to have for that part. Very good. So with this, we continue with the algebra, and the idea is that since here is a, we want to achieve s minus a. So we have to do all that we can to get that. So don't forget, if you have minus 2a, this is the same as minus a minus a minus a minus a squared. Alright, so with this, we can write it as, then we bring that minus a squared. Then we bring plus as. Then we bring the other minus a squared. This is algebra. Very good. Now, when we get this, then I hope you're not confused what is happening here. Alright. Then here we can say that this is difference of two squares. So this is s minus a, s plus a. Plus this, we can factor a out to be left with s minus a. Now we can see that. Now with this, we now get the factorized form. Alright. So we can factorize s minus a out from here, and we are going to be left with, don't forget this is the absolute sign. So we factor this out. So we get s plus a plus a. Hope it's clear. I'm sure. Then here we get s plus 2a. Alright. Then we continue. We want to get s minus a. But here we are having 2 of the a. Oh, this is not going to help us. So we still have to go by the algebra to do something. Now see, we can repeat this s minus a, but with this, we can write s minus a plus 3a. Woo! Hope you can see that. Minus a plus 3a is 2a. So it's still the same thing. Alright. It's still the same thing. Watch. So here we get S minus A into brackets S minus A plus 3. Very good. So S minus A here, S minus A here. Alright. So at first, if we get only S minus A being replace that by what? Delta. So with this, we are going to replace here by delta 1 and here delta 2. In some books, they can make here delta 2 and here delta 1, but it's still the same thing. So delta 1, delta 2 plus 3 A. Alright, very good. Now I'm going to do something, but I'll take it one by one and explain to you. But I want to quote that delta 1, delta 2 rather, and delta 1 is going to be equal to 1, comma. That means that we will choose delta 2 to be equal to 1. Then delta 1 will be epsilon over 1 plus 3 that. Are you confused? Don't worry. Let's take it one by one. Or choose delta 2 to be equal to 1. So it's going to be this. Delta 2 is 1. Now we are left to choose delta 2. But we have to choose delta 2 in such a way that it can come and clear off this. So that means that delta 2 should be equal to epsilon is equal to delta 1 plus this. So to make delta 1 a subject, then delta 1 will be equal to epsilon over 1 plus 3 that. That is why delta 1 is represented here as this. So when we replace delta 1 by this, then the denominator here is going to cancel out this and it will be left with epsilon. Therefore, the question is proved. Hope you can see that. Very technical. Now, less than. Now the delta 1 is epsilon over 1 plus 3 average times 1 plus 3 average of this. So this cancels this. Then we will be left with epsilon. Alright, so that brings the end of that question. We'll be back with the next question. Question 4, we have to prove that this is equal to this. The argument is S and it's over the argument. The argument is over the argument. It's true. But this is equal to this. But how do we prove that? How do we prove that? Sorry, the limit. Prove that the limit. The limit as S approaches A. Prove the limit as S approaches A for today. So, if given any that theorem, always you have to bring it. If given any positive epsilon, there exists delta in terms of epsilon being greater than 0, such that then that. Very good. So here we start. So here we start. This is the F of S minus the L. The L is this. Very good. So having this, we can find LCM. So with this, the LCM is going to be AX. Alright, so this means that A will multiply sine X. Then the S will multiply sine A. So that is what we get. That is what we are going to get. That is what we are going to get for that. So we break this, then A sine X. Now we are going to do something. And that is, we are going to do, let me see. We are going to do and undo. Yeah, let me say it in that way. We are going to do and undo. What we are going to do is that here we have A sine X here. Then we are going to bring minus S sine X. Then, since this is not in this, we don't need to bring minus S sine A. Before we bring minus S sine A, we have to undo the minus S sine X. Don't forget here is A sine X. So we undo plus S sine X. Then we bring minus S sine A. And you can see that everything inside here is the same as what is here. Because this and this cancel out. So you do, then you undo it. Alright. Very good. What is left now? Okay, so you can see here that sine X is here, sine S is here. S is here, S is here. For that matter, then we can factor sine S out here. A minus X over AX. It's the denominator, so we can divide by them. Then here we can factor S out. So sine S minus sine A over AX. Very good. So looking at what we have here, we can clearly see something. And what do we see? We can divide sine S by X, and our reason for doing that I will tell you later. And here will be A minus S over A plus, here this can cancel this. So sine S minus sine A over A. Don't forget that, but the limit as S approaches 0, of sine S over X is equal to 1. Therefore, we can say that this is equal to 1. Because here we cannot put S to be equal to 0, but we can let it approach 0. So if this is 1, then we are going to let it A minus S over A plus sine S minus sine A over A. Here also, don't forget that from From trigonometric identity, sine S minus sine A. Sine S minus sine A is going to be equal to 2 sine S minus A over 2 cos S minus A over 2. Alright, so sorry, this is plus. From trig identity, this is equal to this. And if this is equal to this, instead of writing this, you can write this. So we are going to have that to be A minus S over A plus 2 sine S minus A over 2 cos S plus A over 2. Very good. So that is what we are going to have for that part. And don't forget that there is all over A. So it's going to be all this over A. Okay. So when you get to this part, don't forget that the limits as S approaches 0 of cos S minus A over 2 cos S minus A over 2 is going to be equal to 1. So from my theory, this is equal to 1. And if this is equal to 1, then we are going to replace everything here by 1. And also, we know that this means that we replace this by 1. But don't also forget that the angle of sine S minus A over 2, this can be reduced to S minus A over 2. So this will be 1, then this will be can be reduced to S minus A over 2. So in all, we are going to get by substitution, we are going to get A minus S over A plus 2 will be multiplied by the inside, which is S minus A, then over 2. That will also be multiplied by 1. So we get A minus S over A plus this cancel this. Alright? So, but don't forget that we have A here. So, there's only the sign will go, so it will be like with this. So this cancels this. And this will reduce to this is equal to 1. So it will be like with S minus A over the A. So here A is supposed to be here. Alright, A is supposed to be there. Very good. So we are going to be left with S minus A over A. So that is what we are going to get. Okay. So What this means is that we get a minus s over a plus s minus a over a. And the idea is that we want to get s minus a, not a minus s. For that reason, the absolute sign here means plus or minus. Okay, so we can write this as s minus a over a plus s minus a over a. And this is going to give you 2s minus a over a. 2s minus a over a. Since we have s minus a here, then this is equal to 2 delta over a. Alright, then we choose delta. Okay, so if they're choosing, I said that if you don't know how to choose 8, replace this by 2 delta over this. Make delta the subject. So you get so delta will be equal to this. So we choose delta to be equal to absolute of a epsilon over 2. So by substitution, we get 2 times and this is already here. So this cancel this cancel this. So we get that. Very good. So by the theorem, we have been able to prove that this is equal to that. Very good. It's not difficult, but when you reach here, or when you are starting, don't forget that you subtract not plus s minus s first. I've been that part, but rather minus s sine x. Then you will do it plus x sine x. Don't make plus x sine x minus x sine x. When you do that, that is when you begin to confuse yourself and be beating yourself with the question. That is not how it's supposed to be. Very good. Thank you and see you in the next video. All right, from your idea, okay, I would like you to try your hands on this question. Okay, it's not difficult. All right, see you in the next video.